A multi-million-dollar development can be compromised by one simple oversight: an incorrectly graded slope or a miscalculation in soil stability. Effectively managing these risks is the difference between a successful project and a costly failure. At AXA Engineers, we have spent over 15 years helping our partners avoid these mistakes by developing tailored standard operating procedures, SOPs, for each project. In this educational guide, we reveal the 5 essential site design secrets that our teams use to ensure project integrity from the ground up, safeguarding your budget, timeline, and professional reputation. A common misconception frames site grading as an exercise in creating level building pads and accessible slopes. This overlooks its primary function, the precise management of surface hydrology. For example, a commercial development's grading plan may appear adequate, specifying standard slopes towards storm drains. However, the design might rely on generic rainfall tables, failing to incorporate a hydrogeological analysis of the site's less permeable soils or to model a regional 50-year storm event. The plan is compliant in theory, but untested against extreme, yet foreseeable conditions, creating a hidden liability. During the first significant post-construction rainfall, these deficiencies become apparent. The storm's intensity generates uncontrolled sheet flow across parking areas, overwhelming the capacity of curb inlets. Water pools against the building's foundation, exerting hydrostatic pressure on waterproofing systems and creating pathways for moisture intrusion. This causes immediate operational disruptions and initiates the long-term risk of structural degradation from water damage, necessitating costly future remediation. The failure stems from a design process that treats grading and drainage as separate tasks rather than as a single integrated water management system, a critical oversight for any project. An effective design preempts such failures by incorporating purpose-built hydraulic controls. Engineered swales are a primary tool. Unlike simple ditches built for conveyance, these are broad, shallow, vegetated channels with specifically calculated cross-sections and longitudinal slopes. Their design is intentional. The wide base and gentle side slopes reduce runoff velocity, while the vegetation increases surface roughness. This combination maximizes the water's residence time, promoting infiltration into the subsoil and allowing suspended pollutants to settle. By reducing peak flow rates and runoff volume, swales act as a crucial component in the site's overall stormwater management strategy. Correspondingly, strategically located impoundments are essential for handling large storm volumes. Detention and retention ponds are critical infrastructure components, not landscape amenities. Their size, shape, and outlet structures are dictated by hydrological modeling. A detention basin temporarily stores runoff from a major storm, releasing it slowly through a controlled outlet to prevent downstream erosion and flooding. A retention pond maintains a permanent water pool, offering enhanced water quality treatment via biological processes. The sizing of these facilities involves complex calculations, accounting for the watershed's impervious area, soil types, and regional rainfall data to meet regulatory discharge limits. AXA Engineers validates these designs using advanced software. We employ 3D terrain modeling in Autodesk Civil 3D to build a precise digital twin of the proposed grading. This model is then integrated with hydrological simulation software, like the Stormwater Management Model, SWMM, allowing our teams to test the site against various scenarios, from frequent storms to extreme events like the 100-year 24-hour storm. Visualize water flow, accumulation points, and inundation depths, which enables us to identify and correct potential system failures before construction begins. This data-driven approach moves beyond prescriptive minimums to forge a resilient, site-specific solution. This analysis elevates grading from a basic task to a foundational component of project risk management. Mastering surface hydrology ensures long-term site stability, preventing the operational disruptions and repair costs associated with flooding. By engineering a system that performs predictably under stress, we directly protect the client's capital investment. The project's financial viability is therefore directly linked to the quality of its water management design. This level of foresight demonstrates a proactive partnership focused on protecting asset value from the initial design phase and ensuring integrity against environmental variables that exist just above the ground surface. the most significant liability in a site development plan remains entirely invisible during the initial design phase: the complex, often misidentified network of subterranean utilities. A project team often begins work by clearing a site for excavation based on existing municipal as-built drawings. These documents, frequently decades old and compiled from various unverified sources, are notoriously inaccurate. Nevertheless, the design process moves forward under the critical, yet flawed assumption that these records are a reliable representation of the subsurface conditions. This approach creates a latent risk that will only materialize once ground is broken, and by then, the consequences can be severe and disproportionately costly. The tension manifests abruptly during mass excavation. An excavator bucket, operating according to the design plans, strikes an object not shown on the drawings: an unmarked high-pressure gas line or a critical fiber optic telecommunications trunk. The immediate consequences are a cascade of failures. All work stops instantly as emergency protocols are enacted and first responders are mobilized. This event triggers notifications to regulatory bodies, often resulting in significant fines for utility strikes. The project timeline is completely derailed, facing indefinite delays while the damaged infrastructure is repaired, investigations are conducted, and new work plans are approved. This single incident can jeopardize the entire financial structure and schedule of development. The core issue is a systemic over-reliance on outdated documentation, compounded by a failure to implement a rigorous physical verification process before finalizing the design. This oversight is a common characteristic of inexperienced teams who may accept record drawings as factual representations. Veteran engineers, however, operate on the principle that as-built drawings are merely a starting point for investigation, not a definitive map. While comprehensive records research is a mandatory first step involving collecting drawings from every known utility provider, municipality, and prior development, it must be followed by advanced physical mapping techniques to reconcile the documented information with the actual ground truth. Want safer, smarter development? Let's explore underground risk solutions. First, use ground-penetrating radar, or GPR. It sends radio waves into the ground, detecting hidden pipes and cables without digging. GPR creates a preliminary utility map, giving you an instant overview of underground hazards, saving time and avoiding costly mistakes before any construction begins. Next, targeted vacuum excavation, also called potholing, physically exposes utilities with high precision. It uses pressurized air or water and powerful vacuums to reveal exact locations and depths, offering super-accurate data for final design. Beyond utilities, vacuum excavation allows soil sampling. This helps analyze soil strength and stability, crucial for safe foundations and drainage systems, reducing project risks and delays. AXA Engineers synchronize all these steps with other design phases, speeding up decision-making based on verified info, minimizing guesswork and shrinking project timelines. This integrated approach turns uncertainties into manageable variables. It's about combining utility detection, soil analysis, and sustainable planning, working together for a safer build. Choose AXA Engineers today. Trust experts who plan smart, protect your vision, and build success.